In this video, we'll solve a couple of Venn diagram problems. But before we do that, let's remember that A union B is equal to the set of all numbers from A and B written once. So if 2 is in A and B, we don't write 2, 2. We write only one time. A intersection B is the set of all common numbers. So if 2 is in A and B is going to be in the intersection. And A prime means the complement of A, and it's the set of all numbers that are not in A. And that is usually given a bigger set where we compare with A. But let's get back to our problems. So let's take a look at the problem that we have here. We have these diagrams. We have diagram A. So if you think about it, diagram A is this whole circle. So basically, in A, the terms that we have, or the elements that we have in A, are 1, 2, 4, and 5. These are Roman numbers, the ones that I highlighted in yellow. Now B is the whole circle that has B. So basically, if I draw the boundaries of this circle, what is in this green are all these numbers that are highlighted in green. So in B is 2, 3, 5, and 6. And now let's take a look at C. C is the set that I'm going to, well, I'm going to try to figure out in which color. Unfortunately, purple is not going to work out. Let me see what happens if I with orange. So it's not going to work out with any color because it's going to change my range of colors. Anyway, I am going just to circle, make the circle to show what C is. You see, it's just the colors. Purple with green becomes black, and purple with yellow becomes red. But I want to say that this whole circle here is C, which means there are elements 4, 5, 6, and 7. So we figure out what A is, what B is, and what C is. So in the first part, we have to calculate what is A union B intersection C. So the very first thing that I'm going to do, like in order of operations, I'm going to calculate B intersection C. So B intersection C, it's actually all the terms that are common. So taking a look at the circles, the B and the C, where do the circles overlap? This piece here would mean their intersection. So the two circles, the green circle and the purple circle, overlap at these two elements, 5 and 6. So we put 5 and 6. And so now we have A union B intersection C, which means union means all the elements. So the elements in A are all these ones. So 1, 2, 4, and 5. So 1, 2, 4, 5. And now we have to add, right, union, put together with the B intersection C, which were 5 and 6, but 5 we already wrote it, so we'll just add the 6. In part B, we want to find out A union B intersection A union C. So like in order of operation, we're going to do each parenthesis individually. So A union B means all the regions from A and from B. So A is this one, and B is this one. So everything together, and we actually have them enumerated here. So I just look at A and at B and copy everything that I see, but only once. So 1, 2, it's in both of them, so we copy it only once, and then 4, 5, and 6. And we figure out A union B. Now let's do A union C. So A union C, again, it's going to be A, this green, the blue one, and the C. So we copy everything that we see in A and C. So it's going to be 1, 2, 4, 5, 6, and 7. And now in between them, it's intersection, which means we have to look at all these and copy only the common parts, only what is in common in both of them. So what is common? Well, 1, it's common. 2, it's in both of them, right? 1 is here, 1 is here. 2, it's here, 2, it's here. 4, it's common. 5, it's common. And 6, it's common. So the only thing that is not in both of them, it's the 7. And very interesting observation that we actually got the answer from A. It's identical with the answer from B. So basically, when we have A union B intersection C, we can actually say that it's equal to A union B intersection A union C. So basically, it's like a distributive property. And one more example. What if you had to calculate A intersection B intersection C? So basically, what does that mean? It means what value it's in all these sets. So if we take a look at A, which is here, it contains 1, 2, 4, 5. B contains 2, 3, 5, 6. C contains 4, 5, 6, 7. So let's see. 1 is not in all of them. 2 is not in all of them. 3 is not. 4 is not. 5 is here in A, 5 is in B, and 5 is in C. So 5, it's common. Let's see, 6. No, 6 is not in A, 7 is not in A or B. So graphically, if we take a look at the Venn diagram, A intersected with B is basically 2 and 5, and intersected with C, where do all intersect? They intersect in this region here, which is actually this tiny green region, which is actually made just by element 5. What if we had to calculate A union B union C? Well, we would have to write all the elements that are in A, B, and C. So basically it would be 1, 2, 3, 4, 5, 6, and 7. Because this 8, it's outside A, B, and C.